Hello, we are Justin, Hendra Faris, and myself, Christian. We are going to present a research of hydrogen and methanol turbocharged engines. Global warming is increasing each year, in which aviation industry contributes 2.1% of pollution. In this way, one of the methods that reduce this problem is to change the oil consumption, which fuels are taken as a consideration for the purpose of this research: Jet A1, hydrogen, and methanol. In this presentation, we are going to present about the possibility of hydrogen and methanol as prospect for Jet A1 fuel substitution, which power specific fuel consumption is analyzed depending of the fuel type of the relation of technical modification based on the substitutions of the aircraft. Firstly, I will talk about inputs, assumptions, and limitations. Secondly, Justin and Hendra will discuss about outputs, results, and response to task 2 and 3. And finally, Faris will conclude with recommendation and response to the task force. In the first table on the left shows 3 different types of fuel with their properties, which are relevant for the purpose of the research, including viscosity, density, freezing point, and others. The second table of the right illustrates the parameters that were considered for the elaboration of this research, such as the speed of the sound with 306 meters per second, an altitude of 80,382 meters, and temperature of 234 Kelvin, and others. The assumptions that were taken as a consideration in order to obtain relevant information to calculate power-specific fuel consumption are: assume that the aircraft cruise at Mach number of 0.7. Assume that the ideal cruise altitude is 27,000 feet, as it should cruise between 25,000 and 3,000 feet. Assume that the efficiency of turboshaft and turboprops are the same to all types of engines. Assume that the engine is a single pull-free turbine. Assume that all components of the engine are equally efficient. Assume that transmission efficiency is 1, and others. Now Justin will continue with the rest of the presentation.
The team has plotted 3 different graphs on all types of fuels: kerosene, hydrogen, and methanol, using the model inputs and assumptions mentioned by Christian. A study confirmed the values of Jet A1 fuel before plotting the graphs for all fuels. There are 3 types of graphs presented: PSFC versus compressor pressure ratio, PSFC versus turbine pressure ratio, and PSFC versus Mach number. This slide presents the Jet A1 fuel, which is not presented in the report. The next slide is methanol and hydrogen. As shown in the slides, all fuels behave similarly with different parameters. Power-specific fuel consumption increases as the compressor pressure ratio and Mach number increase. In the case of turbine pressure ratio, increasing the ratio reduces PSFC. It is worth noting that the highest turbine inlet temperature will have the lowest PSFC for compressor and turbine pressure ratios. For a given Mach number variation, the highest efficiencies with the same value for all components will have the lowest PSFC.
Within task 3, we had to calculate the fuel and range for the aircraft. Initially, we had to find the correct aircraft to be able to fly from point A to point B. Initially, we found the aircraft, the Bombardier Dash 400, as a reliable source to take you at a short distance. It's a propeller, and it can be able to fly at a certain equivalent area. Also, the horsepower would be a Pratt Whitney. We indicated that the volume density would be better if it was Jet A1 fuel, as the volume of the volume would be 5.3 cubic meters, meaning that the aircraft will have available space to rely on the luggage or storage or cargo and so on.
Modifications to the aircraft. Hydrogen and methanol can be used to substitute Jet A1 fuels through the use of fuel cells, which will supply the energy electrically, thus reducing pollution and CO2 emissions. The only emission is water vapor. Fuel cells can be connected in a series or parallel circuit depending on the range it travels. Fuel cells removes the use of central hydraulic system and bleed air. A converter or inverter must be used with fuel cells because the amount of energy it produces is unfiltered. For methanol, the fuel cells are known as direct methanol fuel cells. Thank you for watching. We hope you enjoyed the presentation. Thank you very much.